have honored him with awards. In April 1993, he was honored with the title Rajashri by Shankar Dayal Sharma, President of India. Dr. Hegdeji has also been honored with the Padma Bhushana and Padma Vibhushana Award, India's third and second highest civilian awards during 2000 and 2015 respectively. He has been awarded with Karnataka Ratna for the year 2009 in recognition to his outstanding contribution to humanity. Dr. Hegdeji's 50 years of path-breaking contribution to social, economic and cultural development of society is what truly defines his unyielding service to the nation. He has always gone beyond his scope of responsibilities, and this is because of his relentless drive to redefine dharma and his passion for the betterment of the mankind. Sir, for your motivation, vision and guidance has made us to serve the student community as a whole to society with commitment and dedication. On behalf of panelists, attendees, I humbly request your good selves to give opening remarks and declare the panel discussion open. Sir, over to you.
Panel discussion on relevance and outlook for mechanical engineering hosted by the Society of Automotive Engineers India in collaboration with SDM CET Dharwad. Indeed, it is the need of the hour for the industry and the institutes to come together and discuss the trends and cutting-edge engineering technologies. Industries and academic institutes should come together and form a synergetic integration so the society shall be benefited at large. The practices and standards that exist in industry should be shared to the academic institutions so that the institutes can adopt these norms and make students industry ready. Industry can also use the expertise of the academic institutions to solve their problems. I hope this panel discussion throws some light on the future of mechanical engineering and other fundamental branches of engineering where the interest of the students is in a downward trend at present. The deliberations can also be done on why this downward trend in core branches. Also, the panel can suggest some measures to boost the interest of the students to take up the core branches of engineering and curriculum changes that can be made so that the society can be benefited at large. I thank and congratulate all for involving in such an initiative, and I wish our college will take such initiatives in future and lead the discussions for the future course of benefit of the students and the engineering colleges. May Shri Manjunath Swami bless us all. Thank you.
Thank you, sir.
Thank you, sir. Thank you for your kind words, vision and keynote address for the today's panel discussion. With your permission, we will proceed further, sir. Thank you, sir. Next, I would like to introduce Mr. Damodaran Subramanian, Chairman, Management Committee, SAE India, Bengaluru Chapter. Damodaran sir has 3 decades of engineering industry experience. He is one of the early adopters to institutionalize design projects for the global car companies in India. Later, he moved to aeronautical business to develop engineering service business with French aerospace major Safran. He started his career way back in 1990 in heavy automobile manufacturing company Ashok Leyland. Later, he worked in Detroit-based engineering service company EASI, managing the Indian business unit delivering offshore engineering services for US and European customers. He joined Safran in November 2004 to nurture and manage their Indian engineering unit in Bangalore and worked on several trans international projects, including Boeing 787, Airbus 380, Airbus 350. Before taking up the role of managing director, he held the position of senior vice president, currently pursuing the role of managing director, currently pursuing his research and advisory in renewable energy technologies and digital technologies. On behalf of panelists, attendees, I humbly request your good selves to give opening remarks. Over to Damodaran sir.
Thank you very much. I hope I am audible.
You are audible, sir. You are audible.
Thank you. So, first of all, I congratulate the organizers of this particular event. This topic is very close to my heart. I'm a mechanical engineer, started with a diploma in mechanical engineering. Even I could not get an opportunity to go and do 4-year BE program. But it was my always belief and dream. Mechanical engineering is the foundation for all the sciences because I learned everything when I was in mechanical engineering. And very interestingly, in the last 25 years, I go to all the colleges. That is my personal ambition and motivation. I spend half a day with the faculty, students, that why you should pursue a mechanical engineering. I'm not comparing that it is inferior or superior. That is the foundation for any country's technology. You name any technology without a mechanical system, there is nothing. Whether you take a automobile or an industry or an aircraft. I myself is a best example. Because of my foundation in mechanical engineering, later I pursued my information technology. Even today, I'm a student. I enrolled myself for my PhD program. But I always believe without the mechanical engineering, it is very hard for us to sustain in the technology field. I wish all the best for this particular conference, symposium, and panel discussion. We all got a common responsibility to go back to the students and motivate them. They should not get lured by a quick win or opportunity. Especially, we are talking about so much of revolution in the Indian industry. We need to strengthen our mechanical capability in the coming decades. So we have a great future. I wish all the best for the organizers and panel discussion team. Last but not the least, I once again render my sincere thanks and gratitude for the management of SDMCET. Thank you very much, sir.
Thank you, Damodaran sir. It was nice to hear from you how you started your career and then some key words for the student community as well. Thank you, sir. We will move on to most interesting session of today's event, that is a panel discussion wherein we have personalities from leading industries like Vitesco Technology, Mr. Girish Ramaswamy, Mr. Rakesh Bidre, TCS General Manager, Mr. Naveed Talib, Head Manufacturing Honda Cars India, Dr. Ahuja, Director and Professor, College of Engineering Pune, who also happens to be our proud alumnus from first batch STMCT, Dr. Sudhindra Kaushik, Volvo Motors, Dr. DK Subramaniam, retired professor IIC Bengaluru and member governing council, Dr. K Gopinath, principal STMCT, and this session will be moderated by Javji Muniratnam sir. I request Muniratnam sir to take over the session of panel discussion and introduce the panelist to the gathering. And before that, a small request to the audience, in case if you have any questions or queries, you can send them through chat box, which will be taken up at the end of panel discussion. So we will entertain from student community, academicians, as well from the parents. Over to Muniratnam sir.
Thank you, Professor Sunil Saab. Thank you so much. Thanks for the opportunity for us. Once again, good morning to all of you. It's a great pleasure to have such a highly distinguished guest like Dr. Virendra Hegdeji and Dr. Gopinath and the rest of the delegates. And most importantly, the purpose of this specific event is towards addressing the relevance and importance of mechanical engineering going forward. And I'm very happy to see that many students have participated in this. So to begin with, I just wanted to let the students know that rain or shine, we have this event going on. You know, across Karnataka seems to be raining, but we are able to get connected. Similarly, whether it is artificial intelligence or machine learning, the mechanical engineering will continue to survive, and it has to be there as long as the humanity exists. Because you can design digitally anything, but why do you design digital anything? You got to use it physically. You cannot move from A to B. You cannot have your food without the physical things. And that will be done by mechanical engineers. With this, I request Dr. Gopinath, principal, and 1 second, I need to open the brief profile of Dr. Gopinath. I would like to introduce Dr. Gopinath, Dr. K. Gopinath. He's PhD from in mechanical engineering, VTU, MTech heat power engineering from NIT Surathkal, then B mechanical from Karnataka University. He has been with SDM CET since its inception. That means this college is baby, adulthood, and mature person under his guidance and mentorship. He has held various positions, and he has been mentoring not only the college but also the entire VTU faculty. He has steered many programs under VTU. Sir, I request you to kindly give us an opening remark to start our session today. Over to you, sir. Thank you so much.
Thank you, Muniratnam sir. Om Shri Manjunataya Namaha. Good morning to one and all. Respected Revered President Padma Vibhushan Dr. Virendra Hegdeji, our Vice President Surendra Kumar sir, Mr. Girish Ramaswamy, Head Engineering Vitesco Technologies Private Limited, Bengaluru, Mr. Sudhindra Tirth Kaushik, Director Volvo Bengaluru, Mr. Rakesh Bidare, General Manager TCS Bengaluru, Mr. Naveed Talib, Honda Cars India Limited, and renowned academicians Dr. D.K. Subramaniam, retired professor, Indian Institute of Science, Bangalore, and also Governing Council member of SDM College of Engineering and Technology, Dharwad, Dr. Bibi Ahuja, Director and Professor, College of Engineering, Pune, and also proud alumnus of SDM CET, Dharwad, Mr. Damodaram Subramanian, Chairman, SAEINDIA, Bangalore section, and Mr. Jauji Mundratam. Fellow colleagues, parents, and students, I am very happy to participate and make opening remarks for this panel discussion on the subject relevance and outlook for mechanical engineering, which focuses on the following issues. First one, relevance of mechanical engineering in the present day scenario. Second one, preparedness of academic institutions to face the present day challenges. Third one, industry expectations from academia. Fourth one, impact of electronics and software in mechanical engineering. And last one, industry collaboration with academic institutions. The reason for this proposed brainstorming session or panel discussion is because of the directions given by our revered President, Puja Dr. D. Virendra Hegdeji. He visited our college in the month of September 2020 and inquired about the admission status of the college for that particular academic year. It is a well-known fact that admission to non-IT branches was not encouraging not only in SDM city but across the state and country. Our revered president was well aware of these facts and he expressed his sincere concern for the poor admissions of non-IT branches. He was definitely not worried about the income from these branches, but was worried about what might have gone wrong amongst the students and parents getting into these branches. He also said that after the first wave of pandemic corona, the sale of automobiles registered a highest sale of vehicles. Despite this resurgence in automobile industries, he said he was unable to understand poor admissions in mechanical engineering department across the country. He directed us to have a brainstorming session with top level industrial people and academia so that we come out with a proper solution for this problem. He wanted SDMCT to be a trendsetter to overcome this problem for the benefit of society at large. I wholeheartedly thank our revered president for the direction given to me to conduct this panel discussion. Dear friends, all of us know that mechanical engineering, electrical engineering, and civil engineering are the main three pillars for any engineering education in India for ages. All other branches of engineering other than these three are the offshoot of these three main branches. We know that infrastructure development is a continuous process for developing any nation. For any infrastructure development, we need engineers from the basic departments like mechanical, civil, and electrical. But looking at the market demand of engineers, it is a well-known fact that only engineers related to IT branches are in large demand now and are paid well by the IT industries compared to non-IT branches. Even there is a trend of late by non-IT students to join IT sector for their survival. It is high time for industry and academia to come together and revive non-IT branches so that the lost glory of these branches may be regained. Dear friends, SDMCT is an autonomous engineering college affiliated to Vishveshwaraya Technological University, Belgaum. We have a full freedom to design our curriculum as required by industries. I would like to bring to kind notice that our non-IT branches have representatives in board of studies of their departments from well-known industries and also institutions like IITs and NITs. I am pretty sure that our curriculum is well designed to cater to the needs of industries and their present trends so that the students coming out of SDMCT are almost ready engineers and they are employable. In spite of our best efforts, we are also surprised at the poor trend of admissions to non-IT branches during last year. However, our admission to non-IT branches under such circumstances is one of the best in Karnataka state. In view of the above points, I request all dignitaries present today to find the root cause for the present trend of low admissions, their relevance and outlook, and steps or actions that can be taken to improve the knowledge of students about these basic branches of engineering so that these basic departments can attract more students in the days to come. I request each one of you to give your valuable suggestions as well as solutions. Having said the above things, it is my gut feeling that the above phenomena is a passing phase for non-IT branches, which appears to be a cyclic phenomena every 10 years. Some 10 years back, I remember there was a large demand for non-IT branches and less demand for IT branches. With the development of changing technology every day, I hope in the coming days there will be stability for all branches of the engineering with certain changes in our curriculum for non-IT branches with the help of industries. Thank you one and all.
Thank you, sir, for your kind words and elaborating how colleges started different branches. And you rightly highlighted that the three fundamental branches, mechanical, civil, and electrical electronics, is offshoot. Three even talk like document.
Muniratnam sir, we are unable. Voice is getting break.
Deeply involved with academic and development relation for over 3+ decades, and we were also deeply involved with. Yes.
Muni, I think your voice is breaking. Probably you can switch off your camera.
Okay. I will stop the video.
Yeah.
Probably that would have.
Yes, please.
Sir, what I want to ask you is that you have been deeply involved with the academic side and industry relationship for over 3 decades. You are also deeply involved with the Institute of Engineers. I switched around. I
Muni,
switched
I
off
think
the.
we lost you.
Is it
Oh,
to
still
now?
breaking. Still breaking.
Is that okay?
Now it is better.
Okay.
Now better.
Sir, it was not that audible. You have been deeply involved with the academic side and the industry development for 3 decades plus. You are also deeply involved with the Institute of Engineers. What is your take on the challenges faced by Indian curriculum or railway system? Still breaking. Sir, please, hello.
Yeah, very
Good,
much.
good.
It's okay now.
Yeah, I posed my question to Dr. Gopinath. Sir, was it audible to you?
Please go ahead, sir. Muniratnam sir, please go ahead.
Yes, sir. I wanted to know from Dr. Gopinath, what are the challenges faced by
Yeah.
the universities in redefining the syllabus based on industry input?
Yeah. Can you repeat, Muratnam sir? It's not clear. Not clearly audible.
Okay, I will do one thing, sir.
Yeah.
Just give me a few seconds.
Yeah. Muniratnam sir.
Yes, sir. Yes, sir. No, I
Yeah.
wanted to know.
Yeah, please go ahead. Yeah, tell me. Now your voice is clear.
Pravul, I will repeat his question, sir. What he is trying to ask you to
Yeah.
elaborate on the preparedness of the university from the perspective of mechanical engineering. Are there any changes, and also what are the challenges you are facing to bring up to the speed so that mechanical engineering syllabus can be slightly tweaked so that it is on par with the need of the industry as well as the market.
Yeah, I got your question, Girish sir. No, as far as SDMCT is concerned, I have a total freedom in framing my curriculum because I'm an autonomous engineering college. Is it clear? So V2 has no hold on our curriculum, but as far as SDMCT is concerned, our mechanical engineering department has in their board of studies people from IITs and people from big industries nearby and also from Bangalore. So we always take input from industries, also input from very good institutions like IITs and NITs, and frame our curriculum. We have some electives which have been designed by Infosys and also Tata Technologies. So I feel our syllabus is pretty good catering to the industry needs. But in spite of this, Girish sir, I already mentioned that there is a downtrend in getting students admitted to even SDMCT. Probably it is because the placement of core mechanical engineering department very poor, because people who were come to SDMCT to hire my students, it's always software-based companies only, less of core companies visit our college. So we are trying our best, and now we have national education policy wherein most of the thing is based on which is syllabus is based on skill education. We are trying to develop more skill-based curriculum into our syllabus. Thank you, sir.
Thank you, sir. Muni, are you back?
Yes, I'm back.
Okay.
Is it better now?
Yes, better now. Please go ahead.
Okay, thank you so much. Sir, thank you for your great input, sir. This is great assurance for the industries that universities and colleges are able to meet the industry requirement in changing the course curriculum based on the request from the industry. That's great to know. I'm very happy to hear. Thank you so much.
Thank you, Murugatnam, sir.
Thank you, sir. I'd like to introduce Dr. D.K. Subramaniam, sir. And he is distinguished fellow of the Institute for Development and Research in Banking Technology. And he is a member of Research Advisory Board for Tata Consultancy Services. And he is also IT advisor for Punjab National Bank. And he has been with one of the top institute in the country, Indian Institute of Sciences, for over 37 years. And he's a PhD from Computational Methods and Optimization from Indian Institute of Sciences and a Bachelor's of Engineering from Tyagaraja College of Engineering. Sir, it's a great pleasure to have you on the board with your very rich experience. Sir, my question to you is based on your very rich and vast experience. Probably you might have seen mechanical engineers playing a very high roles in the banking industry, in the finance industry, in the IT industry. What do you feel is advice? What is your advice for the colleges and the students? And most importantly, to the parents who feel that students have to study only IT related topics. Over to you, sir.
Thank you. It's quite a nice question you have posed me. I hope you can all hear me clearly.
Yes,
I think. Let me thank both SAE and SDM for a very thought-provoking panel discussion on a topic of crisis today. It is not a topic of interest today, topic of crisis today. And let us look at quickly a little bit about mechanical engineering. What really happened was we started with motion, then moved to electric, moved to energy, then we moved to mechanisms, and then control. You know, we keep moving there, and then design, and then manufacturing, and so on. But what really happened was, while the industry, you see the automobile industry or the aircraft industry, while the industry has adapted a lot of electronic computers and AI technologies into them, somehow our syllabus, college's syllabus, stays dated to 80s. I've seen it in several institutions. There are various reasons for that. I don't want to get into it because I don't have much of a time. But the thing is, the technology has been leapfrogging. We are now talking about IoT, we are talking about AI, we are talking about cloud, edge, and then we talk about a driverless car. When you talk about a driverless car, can students, mechanical engineering students, get into a driverless car industry? So that's the kind of question I have. So which means we need to put in a lot of effort in modernizing the course. It is not, as the people are thinking, a small change in the curriculum is going to make wonders. Absolutely not. It will the basics of fluid mechanics, basics of mechanisms, motion, thermodynamics are all well placed. Now we tried an experiment of mechatronics, okay, and there are institutions which large number of students do a project on robotics. So you see that how much of robotics is there in the curriculum? That's the kind of question we have got. Okay, the problem is faculty retraining is a problem there also, because that's the situation. For instance, there is a new area which is now coming up, which is almost 3-4 years old now, which is called the cyber physical systems. Can I suggest that the mechanical engineers look at cyber physical systems as as a framework on which to build the mechanical engineering into it? Okay, I don't think mechanical engineering will survive as mechanical engineering alone. But remember, even in the olden days, mechanical engineering did not survive as just motions. It had energy, it had combustion, it had thermodynamics. So kindly understand that mechanical is a mix all the time. So today I think we are talking about robotics, we are talking about AI, we are talking about edge and cloud, we are talking about a lot of things, okay? The IoT has changed the way you might have been designing your cars, your various things. And you do find that I'll just start with a quick question which was asked to me a couple of days back. Somebody asked why these automobile industries are cribbing about non-availability of chips. So he thought mechanical means only where the car has got transmission and combustion and engines. But where does this chip coming in? So we have a lot of controls. We have a remote starting. We have a lot of things, and we need lots of chips. So if you want mechanical engineering, the people should understand something about the chip culture, how exactly chips fit into it. The best solutions I have is, first is revamp the curriculum. Two is at least every student should do an interdisciplinary project. Increase the number of projects, students should do at least one. Three is, I think we should, as the national education policy says, reduce the curriculum, increase discussions. Talking should be less, because students can absorb a lot of knowledge from the web, from Coursera, from various other sources. So we need to move towards discussions. I just want to tell you, look at our old traditions. You see Ketopanishad or you see Brihadaranya Upanishad, okay? They are all question answering systems. Very, very complex things like Atman, like Brahman, etc. They are talking about through a sequence of questions. In Ketopanishad, Nachiket goes to Yama and then asks in clarification about that. And the whole thing is a sequence of questions and answers. So we need to rework on that. I recall about 10 years back, more than 10 years back, the Singapore universities, they revamped the curriculum. They didn't revamp by changing the subjects. They said what is called the problem-oriented curriculum. So don't talk of Young's modulus first, okay? Don't talk of Newton's laws first. Talk about the applications of Newton's laws first. Then bring in the Newton's laws, bring in the calculations, bring in the design, bring in the other things. So that creates a holistic approach for this, and the entire set of Singapore polytechnics changed, and they have done wonders in that. So we really need to look at that aspect. And then I would say that the elective side, at least go for 20% on non-mechanical, particularly IoT and cloud and smart cars, driverless cars as you call it, the robotics. Okay, robotics is moving to cobotics. Today, till now, mechanical engineering always looked at machines. Today, Industry 4.0 looks at people first, customer first. All of you know that because most of you The industry people are all sitting here. You know that the industry 4.0 started with mechanical engineering focus in Germany. Okay, so the people first is what we have to really look at. How exactly the operations, the behavior, there's a term called cobot. How humans work with cobots, robots, all these aspects are there. So we need to really have a overall look at the various kinds of things, make a change in our curriculum. Okay, I think that's a brief from me. Thank you for taking me here. I would really like to thank Pujya Manjunatheshwara as well as our Dhammasthala Dhammadhikariji and all of you. It's very remarkable. I have been involved with this college for more than 30 years. Okay, so I know SDM extremely well. Thank you. And I know more than 300 colleges in the country. Thank you. Thank you, Jeevaratnam. Muniratnam.
Muni, are you there? Seems to be we lost him.
This last time.
Okay, I think let's continue. I think before he joins, probably let's get into.
I'm available.
Okay, Muni,
Girish.
please.
Yeah, Girish. I used a different technology in between. Okay, thank you so much, sir. It was a fantastic information to us. It demonstrates the rich experience you have and dealt with so many years of experience and solved many problems. It's so nice of you. In fact, you have suggested 3 important points. I will keep the first point to the last, but what you really mentioned was that interdisciplinary project. That's an outstanding information to us, sir. We also strongly believe from the industry perspective that there is no more highly focused projects for one specific discipline. It has to be interdisciplinary. Based on our experience, we found that the students who have participated in various programs where interdisciplinary activities are demonstrated, those students are able to perform very well in the industry right from the day one. Thank you so much, sir. And you also mentioned about less talk and do more. That's a great thing. I think we will certainly take it forward. And most importantly, you did mention that revamping the curriculum. I'm sure SDCM College will certainly look into this for the benefit of the students and the society in large. Thank you so much, sir. Taking forward your discussion that automobile industry is creeping, saying that they don't have mechanical engineers. I would like to invite one of our distinguished panelists, that is Mr. Naveed Talib. He is Assistant Vice President and Operational Head for Honda Cars India Private Limited. Under him, manufacturing, engineering, quality, and new model development comes under. He's a mechanical engineer with expertise in automotive development, manufacturing quality, and most importantly, sustainability, which is very hard to Japanese companies. He has spent about 3 decades in the auto industry, both in 4-wheeler and 3-wheelers, vehicle development, quality assurance, regulatory activities, and he is also responsible for day-to-day business activities. He has worked in Honda Motor Japan, and he was responsible for technical know-how transfer in the field of development, car manufacturing, and quality assurance. Worked as project leader, team captains of 7 nations, and he has worked on various popular car programs in India, Accord, the CRV, Civic, City, and ZAS. And most importantly, he is the head of technical head for SIAM, which is the Society of Indian Automotive Manufacturers. And he is also working on the working group for Indian regulations and harmonization with the global standards. And he is also pioneered in hybrid activities. So I would like to ask Talib San to share some few important points like this. That is, Philip-san, you have had an excellent journey in automotive manufacturing and R&D arena, especially with the Japanese industry. What is your opinion about the role of mechanical engineers in the manufacturing sector related to Japanese OEMs and its supplier base? Probably you can also address one of the questions posed by Dr. DKS, that automotive industry is saying that we are not getting mechanical engineers. Over to you, Navid-san. Hello.
You're on mute, Navid-san.
Sorry for that. So thank you for that generous introduction, Mr. Muni, and I really thank SAE and SDM College to organize today's event, which is very, very important and which is very, very relevant in today's scenario, where we are, on the verge of a change as far as the mobility is concerned. And many like Dr. DKS said that people are looking more towards the new facets which have come up, like AI, ML, and people think that they need to move towards more towards the software aspects, but actually speaking, you need to look at just look around you. You find everything which is there that is mechanical. Everything in life that you see, if you see with that viewpoint, you'll see that it's mechanical. I myself, I was, I have graduated at a time when people were moving towards software. But then I chose to go into mechanical engineering sheerly because of the love of the automobiles that the love of automobiles that drew me towards going into the mechanical field. So when you see at various aspects which are there, which we see in our day-to-day life, there is nothing that you see can be created or that can be made without the involvement of mechanical engineering. And like in case of automobiles, when we talk of automobiles, it is now becoming a combination of electronics, electrical, and mechanical. So it's time where we need to look at the syllabus which is there in mechanical engineering, that yesteryears, if you look at those that curriculum which is there, be it whether it is thermodynamics or it is even automobile engineering or strength of materials, all these things, they form a basic foundation which is there. But then we need to work on those foundations and look at what is it which is required to be implemented in the practical world, where now we are moving towards autonomous cars, and a lot of machine learning or AI is being involved. So how do we have this relation between what is there in the fundamental education system that we have in the academia at the moment, and what is it that is required in the industry based on the changes which are happening around. So we actually need to look at, like Dr. DK has already mentioned, that we need to look at certain projects which will be cross-functional projects, And these cross-functional projects, like we have a project which is a mix of mechanical engineering, data analytics, or machine learning. Even if we go into Industry 4.0, where we place the customer first, and everything is designed around around people, where we look at the comfort of the person who is working on the line, or the product that we are going to manufacture, the safety of the person who is going to use that product. So how those things can be combined, and how those things can be kept together, that is the thing that we need to look at when we are designing the curriculums and designing the projects for the students. So that's it from my side. Thank you.
Thank you, Navid San. It's a a great input from your side with your rich experience. If this is what we need to do, I think we should look at that. And I will get back to another academician we have on the panel, Dr. Bibi Ahuja. Very brief introduction about him. He is both BA and ME in mechanical engineering, and he has done his PhD in hybrid bearing design from College of Engineering, Pune, one of the, again, a prestigious college in the country. And he also holds a master's degree in management sciences. And most importantly, he has been deeply involved with the CAD/CAM activities, setting up the laboratories, etc., for over 2-3 decades. In the last couple of years, he's deeply involved with All India Board of Vocational Education under AICTE. He's the chairman for the Board of Apprentice Training, and he is also the chairman for. He's also the member of Executive Committee of National Board for Accreditation in New Delhi, and he has won the Best Teacher Award for Government of Maharashtra in 2009-10, and he has won many other awards, including the Institute of Engineers Gold Medal for the Best Research Paper published in 98-99. And he was also invited Fiat Auto in Torino, Italy, as a trainer for metrology and quality control in March 1998. It's very interesting to know that we are able to train the European people. He was also invited as a visiting scientist for JSPS DST Exploratory Exchange under Japan-India Cooperative Science Program in 2010. And he is associated with various R&D activities in and around Pune. He is also the fellow of Institute of Engineers, Indian Institute of Production Engineers. He is a member of Computer Society of India. And importantly, he is also a member of Romanian Society of Mechanical Engineers. So welcome on board. Nice to have you. I have a very simple question to you. You have been involved with the AICT for a very, very long time in different capacities. You have stayed the Board of Apprentice Board under various activities. And please share your views on AICT effort in strengthening the mechanical department students relevant to the industry. And you are in hub of mechanical industry for many decades. That is the Pune. It used to be the hub of automotive. And how did the colleges played a role in ensuring that industry gets the required mechanical engineers, as well as getting the required education or the training for them to be readily acceptable to the industry? Over to you, sir.
Thank you, Mr. Muniratna. Thank you for those kind words that you just mentioned. Words that I do not deserve. Nonetheless, thank you for your kind introduction. Revered Dr. Virendra Hegde ji, Mr. Damodaran, Professor Gopinath, Principal of the college where I studied, Professor D.K. Subramanian, Mr. Navid, the other panelists, Good morning to one and all. I would like to thank Professor Sunil for inviting me onto this panel today, this distinguished panel, and also giving me an opportunity to share my thoughts. Thank you, Dr. Sunil. Thank you, Professor Gopinath, for having me on this occasion. I left SDM College of Engineering and Technology, Dharwad, as a mechanical engineer way back in 1984. And it looks as though I'm still very much there. My heart is with the institute, though I am currently with College of Engineering, Pune. This is by way of information to the listeners who are connected to the panel discussion today. I wonder if the students and the parents know that India is the world's largest manufacturer of two-wheelers and a major manufacturing hub for small cars. India leads in the pharmaceutical sector in the production of generics and formulation. 90% of the world's diamonds are polished in India. We have the world's largest refineries and have become major exporter of diesel and oil. In the automobiles and auto ancillaries, the Indian companies have distinguished themselves globally. Like the Nobel Awards in the Indian manufacturing industry, we speak of the coveted Deming Award. There are over 200 plus, 250 plus Deming Awardee winners, of which 10% are Indians. So mechanical engineering is very much there to stay. It's the evergreen branch of engineering. We talk of the fourth industrial revolution. Professor Subramaniam mentioned of it. We are on the brink of the fifth industrial revolution. But we should not forget that right from the first industrial revolution, which talked of steam technology, it was all about mechanical engineering, civil engineering and mechanical engineering. The first industrial revolution, which emerged in the early 18th century, was based on steam technology. And from there on, we have moved to the current industrial revolution. But each of these has only strengthened the use of mechanical engineering in whatever domain we are today. Because anything that we want to conceive, anything that we want to create, we create a product or a service. Each of this product or service which takes a tangible form culminates into something which is very, very physical. So whether it's a civil engineer, electrical engineer, electronics engineer, computer engineer, IT engineer, each one ends up in making a product. Even if I make a service, if I develop an app, to run the app, I need a gadget or a device. And to do that, I have to depend upon mechanical engineering. mechanical engineering, which emerged from mathematics and sciences. It has a long history. But each of these industrial revolutions, if we see, were paced in different centuries. But with the way technology is advancing today, the rate of obsolescence is growing. They say that the half-life of technology is 2 to 3 years, which means by the time my student, a mechanical engineer, who passes out of the college at the end of 4 years, is the curriculum relevant to him or to her? We are moving at that pace. How dynamic is our curriculum? How much involved or connected are we with the industry? Is a question for each one of us. We were in an era where we said, it was either AD or BC or AD. But today, we are in an era where we say it is either BC or AC. That is before Corona and after Corona. We are in a new regime. We are in a new regime altogether. And this new regime tells us that we have to think very, very differently and act very fast. They say there is no age for learning. And we have to prepare our students. We have to prepare our students for life. Every student who passes out would have a career of about 50 years. And in those 50 years, he would have to work on technologies which are not known today. So how does a mechanical engineer survive for next 50 years after he or she graduates? Which means we have to prepare our students for lifelong learning. That lifelong learning relies on self-learning. So the bottom line is that students have to self-learn today. We as teachers must play a different role, rightly mentioned by Professor Subramanian, that we should not be teaching. We should be facilitators. We don't have a cricket teacher, we have a cricket coach. We don't have a football teacher, we have a football coach. So can we teachers don the role of coaches? Can we be different, only facilitate learning, which means we tell the students that this is the course, as rightly said by Professor Subramanian, that we teach them the application first and then expect them to work on it. India as a country has scope only for mechanical engineers altogether. Come what may, a mechanical engineer would always be needed, because anything that we want to realize, product or a service which takes a physical form, must go through a process of manufacturing. So we have to work on materials and methods of manufacturing. So anything that is related with design, with development, with manufacturing, with testing, with installation, with operation, with maintenance, anywhere, mechanical engineer is always required. I think the meeting today the point of panel discussion today is, what is it that we could do together, the industry and the academia together? How is it that we can bring about this change for people, for parents, for students to realize how important it is to be a mechanical engineer? We would like to share some of the experiments that we have initiated at College of Engineering, Pune. It is all curriculum driven. Our former chairman, Board of Governors, Dr. F.C. Kohli, he said if you want to drive academic excellence in your institution, he said there are three pillars. It's a tripod, he said. You must have the best of faculty, the best of students, and the right curriculum. His emphasis was on the right curriculum. He emphasized, now if you want to create lifelong learners, and in mechanical engineering, which has emerged from mathematics and physics and is based on material science, we have to give our students strong foundation courses on mathematics, in physics, in basic sciences. Today, most institutions believe that we have to pump in all the information to our students, tell them as much as we can. Little do we realize that our students are the brightest lot. Our students they are born with gadgets today. They are born in current technology times. They are ahead of us as teachers. So we should be giving them good foundation courses of mathematics and basic sciences. We at College of Engineering, Pune have mathematics in all 8 semesters of undergraduate education. We have large number of courses in basic sciences. We have introduced interdisciplinary foundation courses, which means every mechanical engineer studying at College of Engineering, Pune takes a course on machine learning, takes a course on artificial intelligence, takes a course on sensors and automation, takes a course on data analytics, takes a course on 3D printing is of course part of mechanical engineering, takes an extensive course on robotics. It's all a part of the interdisciplinary foundation courses. So we have introduced these courses for students to build on so that the industry does not tell us any longer that your students are not relevant. One more initiative that we have taken, we call it the collaborative teaching. Today, COVID has helped us to accept technology in a very rapid way, to move towards digitalization in this digital world. So every teacher shares the curriculum with the industry expert, an expert who also has a passion for teaching. So every teacher must find an industry friend. Share the curriculum with the industry friend and ask that industry friend, ask him or her, who is the industry friend, to deliver on different topics of the syllabus, case studies of the industry on relevant to my syllabus. So when those case studies are brought by the industry expert to the class, students learn faster because it is all about application. So I cover my course, I cover 40 hours of teaching, another 30% or maybe more every teacher has the liberty to invite the industry friend. So 30% is the minimum. It could be 40%, it could be 50%. If it is 30%, which means additional 12 lectures to be 30% of 40 hours. So instead of student learning 40 hours, he's learning 40 hours from me and another 10 to 12 hours from the industry expert who takes only case studies and tells the students the roadmap of technology in those courses. So there are basic foundation courses. There are courses which are applied in nature. And for those courses, we have these industry experts. Then the industry is no longer telling us that your mechanical engineer is not relevant. And today we have realized with this online teaching, the industry expert could be sitting miles away from us, but he is easily accessible. He can communicate with the students and deliver those case studies. Students become enriched because they have gone through what the industry is currently doing. We have projects for students right from the first year. Every student has to take up a project in the first year, in the second year, in the third year. So they have projects which are again interdisciplinary in nature. And the final year project is a project where a student, we don't allow students necessarily to work from only mechanical engineering stream on a final year project. He must find his partner from electronics branch, from computer branch. Right? We also have introduced, so the project becomes interdisciplinary. We also have introduced honors and minors. A mechanical engineer, he wanted to major in software engineering, he can take minors in software, but he will be a mechanical engineer. So he has a minors, or he can have an honors in automobile engineering if he so desires or she so desires. So a blend or a variety is brought to the mechanical engineer because mechanical engineering is all about breadth, it's all about flexibility, it's all about individuality. And that individuality is brought about by a combination of these factors, working in different domains, bringing them the current knowledge that is required. And we say that we have to bridge theory and practice, which means every mechanical engineer must also have coding skills. So I'm sorry.
No problem. So we can conclude. Yes, please. Go ahead.
Yeah. I'm sorry. I think I have.
No, it is extremely informative.
No,
honestly, sir.
we
extremely
can.
informative.
I will. Yes. Listen to the other panelists also, and maybe if there is time at the end, I can come back.
Yes.
And Thank you so much.
No, sir. My humble request is you are about to.
I'm sorry. You know what happens when you ask a teacher to speak and you give the teacher an audience, the internal clock is set to 60 minutes. I lost track of time, right? So my apologies to everyone on the panel and the listeners. Yes, I can share my thoughts towards the end of the session. Yes.
Sir, first of all, I would like to thank you wholeheartedly, personally from my side as well as from the entire team here. What you highlighted is extremely important. Many of us students, sometimes we as parents as well, do not highlight the size of this country in terms of what we do. For example, you said we are the largest two-wheeler manufacturer in the world, which means completely mechanical industries behind that.
Absolutely.
Number two, the highest quality award the mechanical industry should get is the Deming Award. And you said that we have 10% of them in this country. It's an outstanding thing to know that. We're very happy to hear, sir. And the other thing is, you also mentioned that AC and DC.
Yes, we are in a new era today, before Corona and after Corona. We have to change our thoughts. We have to move with times.
Absolutely, yes. It's another interesting thing which you also highlighted was that 3 pillars: faculty, students, and curriculum, and collaborative teaching. yeah, that's a great learning and great input for all of us.
Yeah, but
And,
most importantly is the interdisciplinary foundation courses. These are foundation courses, mind you, and these courses have labs. So there is less of teaching of AI, machine learning, more in the lab.
yes,
So it's more hands-on, right?
thank
So,
you.
and we should not wait, for the student to graduate and then bring about a change in our curriculum. We change our curriculum to the extent of 25% every year, which
Great.
is done at something which is done at MIT and Stanford.
Absolutely nice, sir. Thank you so much once again. That I think these kind of things have demonstrated and it is a great impetus to the industries in and around Pune. That's why it is the hub of mechanical companies in India. Thank you so much, sir.
Yeah. And I personally, I would be more than happy to contribute to my college, my alma mater, who has given me so much. So
thank you, sir.
thank you, Professor Gopinath. Thank you, Dr. Sunil. Namaskars to Dr. Virendra.
Yeah, thank you, sir. Ladies and gentlemen, I would like to take a brief pause here. You must be wondering who is this guy who's talking to everybody here. I just would like to give a very brief info about myself. I'm basically an aeronautical engineer with a postgraduate diploma in business management. Spent over 30 years in the industry, both in product development and R&D. Spent more than 15 years in both Europe and US, predominantly in automotive and aerospace. For the last 14 years, been deeply involved with SAE India in various roles. Different roles. Currently, I'm heading an engineering education board, and thanks to all my fellow colleagues who are part of this panel discussion, who are able to serve the society and educating the students, especially mechanical students, to see what is that they should learn so that they can be ready to the industry. As part of SAE, we have various events. I'm sure most of the students know that Baha, Supra, Epicycle, various events. So this is what I do. Coming back to our panel discussion, I'd like to invite our good friend, Mr. Rakesh Bidre. A very brief info about him. He heads virtual integration and safety crashworthiness in one of the largest services company in the world, and which also coupled with the largest automotive company in the world, which is basically TCS and GM. And he's part of SAE India Bangalore section for quite some time, and he's a secretary for that. He is Masters in Global Automotive Engineering from University of Michigan, Masters in Industrial Management, BITS Pilani, Executive MBA program from IIM Bangalore, Bachelor's in Engineering from Walchand College of Engineering, Sangli. He has about 20 years of experience, chassis design, NVH, vehicle dynamics, safety, crashworthiness, MTO, innovation, data analytics, and advanced vehicle development. I'd like to highlight here one of his rich experience is in the last 2 years, he has been part and parcel of an interesting program called Range Extended Vehicle, the Range Extended Electric Vehicle. It is conceptualized by General Motors and SAE India Bangalore section. And he has spearheaded the program. We already had one first event, and we are looking forward for many more such events. And question to Mr. Rakesh Bidre is, you have been part and parcel of the RE program. How do you share your what is called experimental learning? It is not just a project, but how you have evolved this experimental learning for this RE program and other programs like Baha and etc. Thank you so much, Rakesh. Please go ahead.
Thank you, sir. Thanks a lot for a kind introduction, and it's really a honor and privilege to be a part of this panel. And hearing from other panelists, I think I am more enlightened and enriched today in my thoughts about how mechanical engineering needs to adapt to the change, right? So the experiential learning, right, like Mr. Muni, what you said, before I come to that experiential learning, one thing which I wanted to say very proudly that I am a mechanical engineer, and when I joined the industry way back in 2000, that's where, automotive sector specifically was experimenting a lot, right? And in between, there was, I would say, a pause in terms of a lot of innovation coming in. But if you look at last 2 years and for next many years to come, this is the best time for any core engineering aspirant to come and contribute into the industry. Today, I have more than 300 core mechanical engineers as a part of my organization. And I am jealous, I feel envy to them because they are able to do hands-on core engineering work, which I'm really missing today, right? Because my role and my time doesn't demand that kind of hands-on work done by me, but given a chance, I would like to start my engineering career again with hands-on engineering. So this is my, sincere admission to all the, aspirants in this domain that present and upcoming future for these core engineering is really phenomenal. For example, look at the transformation, what is happening in the automotive sector, right? From conventional mechanical systems to electrification, autonomous, ADAS, right? These are sheer transformation in the automotive sector. And engineers are rewriting, today's engineers are rewriting the way the mobility has been seen in the past. I have enough mechanical engineers who just joined a year before and writing patents, innovation in just 1 year, right? Writing papers in SA International Conference, because opportunities of learning and applying what students would have studied is significant. Coming back on the REEV, which is the experiential program, right? So like Professor Ahuja, I think shared almost 80% of thoughts what I had in my mind. So it saved my time, but I'll touch upon some of the aspects which can make this complete, right? The theoretical knowledge or the concepts is definitely, the key, and it's lifelong learning for any individual, right? So it's less about teaching and more about learning, right? So how do I understand the concept, very fundamental concepts of mechanical engineering, right? Just by reading the books or understanding those understanding that fundamental in a real world application. So range extended electric vehicle gives that opportunity for us to really apply the basic concepts of engineering, whether it is Newton's first law, second law, third law. What does that mean, right? How does actually, a system applies that concept? That's the lifelong learning which comes through experiential learning. And forums like range extended electric vehicle or Baha or Supra or any other, student competitions which are anchored towards the learning are the great platforms. The other aspect of experiential learning, and which is key for that matter for any engineer, not only for core engineer, is the soft skills, right? When we as a team try to solve a problem, right, we develop a lot of other soft skills in terms of how to communicate with our fellow colleagues, right? How do we really understand their challenges? How do we collaborate with others? How do we learn from others, right? This is not the time of individual excellence which standalone matters. It is the team which matters in the industry. There could be brilliant stars, but if that individual doesn't understand how to work in a team, has very limited scope in terms of growth in the industry, because industry is made of people, a team, right? So programs like REVE helps to develop those soft skills as well, so that it doesn't increase the probability of a job in the industry, but it helps to set up for long-term career of that individual, right? And through these platforms, whether it is multi-physics or whether it is application of new learnings in the areas of ML, AI, right? Or for that matter, robotics, that knowledge can be applied. And the third aspect is fail fast, right? Conventionally, there is always a fear of failure, whether in our society or in education system. But through these experiential learning programs, it gives us an opportunity to fail and learn fast, right? Because failure is a part of success, right? In industry as well. It's not that whatever products we make in the first attempt is absolutely, bang on. We go through series of failures, learn through that, and that's how any product becomes successful. How does that thought process comes into students when they work through these, programs, right? So it gives the opportunity to develop those skills as well, apart from, your fundamental learnings of mechanical or electrical or, civil, and blend it with the newer technologies like ML, AI. And the third aspect is the soft skills. These three aspects is what I would call reimagining mechanical engineering of future. That's all, Mr. Mani, I have to share. Thank you. Thank you.
Rakesh-san, thank you so much. It's an outstanding feedback to the students and also to us. Fundamentally, you have highlighted very, very important fact that working together is also a knowledge, and that is what the students have to learn. It's a great input. I mean, all of us have seen not only at the time of learning in the colleges, but also in the working environment. How do we collaborate with each other? How do we collaborate with different departments and different people is the key to success and growth. Very happy to hear. And the second very important thing you did highlight is in the current days of fast life, you did rightly mention fail fast. That's very good to hear. Say, for example, today I'm somewhere outside the city. I had a problem with my laptop. I failed, but thanks to somebody suggested that I should switch over to mobile. I switched over to mobile, and the life continues. The program continues. So fail fast is very, very important. And I think students have to really learn that they should not get dejected when they fail. And it's better to fail at the beginning itself. And third most thing you have highlighted was the soft skills. Yes, this has to be part of the curriculum as well. And not only curriculum, in the different projects, what they do in the colleges, I think if it can be incorporated, the soft skills, I think it will pave way to good quality of engineers in the coming years. Thank you so much, Rakesh-san. Okay, moving on.
Muni Ratnam ji.
Yes, sir.
This is Ahuja this side.
Yes,
can
sir.
Can I share a thought?
Please, please. You're most welcome. This is a panel.
Yeah,
yes,
yeah,
sir.
Yeah. So as technology today, it's not confined. It's to one discipline. It's all in the early 19th century. Everything was divergent, and
Yes.
now everything is converging. And what the society needs is a solutions engineer, and who better than a mechanical engineer? It's something that I wanted to say.
Rightly said,
and also what Mr. Rakesh ji just mentioned. I would like to put it in a different connotation, that in life there are no failures, there are only experiences.
Oh, great.
And yes, the saying is fail fast, because you want to overcome that. But there are no failures. There are only experiments and experiences. and we should keep trying engineering and experimenting with engineering. I think that is all that I wanted to say.
Thank you so
Thank you
much,
so
sir.
much.
Yeah,
Thank you.
thank you so much for that excellent information. And
I just add one point to that. When
Navid San. Yes, yes.
when Rakesh spoke about
Yeah.
fail fast. So fail fast, in the current industry, it cannot be about egos, because with egos you may end up with huge losses. That suppose it's my idea and I want to keep on promoting certain idea. And if it's not going to work, and if I come to know that it's not going to work, it's better raise my hand and say that, it's not going to work. Let's think something different there. So that's how, in industry, current industry trend, we don't have space for any egos. And as Mr. Ahuja rightly pointed out, Professor Ahuja rightly pointed out, that it's about experiences. So when you are going to fail, it's also an experience that you are you have the guts enough to raise your hand and say that it's not going to work. So let's think about something else.
Thank you, Navid San. It is very, very interesting information you did give, that the ego cannot be part of our life for a smooth sail of success and everything. And it is being clearly demonstrated, especially by the Japanese industry, where right from the contract worker to the MD of the organization eats the same food in the same, similar kind of environment in the organizations. So that we have seen it when we have visited Japanese companies. It has been demonstrated extremely well. Nice to hear your specific point on that we cannot have egos and thing. Thank you so much.
Sorry, sir. Just to add, and when I meant the fail fast is, as like Professor Ahuja said, it's more of experiment and experiences. Even when we are talking about the core topic for today is, how should we adapt to the new curriculum, right? So these new curriculums are set up those small mini experiments, right, which should evolve than defining, like a goalpost, right? Today's goalpost is changing every day, right? So how do we really experiment, different approaches before we converge on one approach while defining the curriculum?
Thank you, Rakesh, and that experimental learning. Thank you so much. I would like to move on to slightly different. One is we have this excellent gentleman. He comes from a different background, and his longest experience has been the innovation. And he worked with the top-notch innovation companies. This is I welcome Dr. Surindra Tirtha Kaushik. He is the innovation director for Group India Private Limited, head of Campex by Volvo Group Bangalore. He is BE, MBA Marketing, PG Strategy IM, CAPE, and PhD in Innovation. And most importantly, he is a senior member in IEEE, which is playing an extraordinary role in the country and the world. He is also a fellow of Institute of Engineers, and he has been conducting various IEEE programs in the country. And I'd like to, you have been thick of 1 second. Let me get back to my questions. Yes, Dr. Sudhindra, you have been in the thick and thin of innovation in companies like Philips in Eindhoven. It's a beautiful place, and which was actually the design and manufacture of CDs in the world. To share with the rest of the students, CD was designed, developed by Philips, and the laser disc, which is no more used, but a lot of medical equipments today, you go to any hospital, medical equipments predominantly are from Philips. And as they call, innovation is their hub of activities. And he also spent some time in TTK and BPL, which is a homegrown home product company. We have had fantastic products from them. With this rich experience, what is your take on importance of mechanical engineering in the product innovation, productization? Over to you, Dr. Surindra.
Thanks, Muni. I think discussion has been quite serious, so maybe we should lighten up a little bit.
Yes,
So either Muni doesn't believe that I will say something useful, or he knows what I'm going to say, so he put me in the last. So that's okay.
No, not at all. We have one more question.
No, I'm just pulling your leg. I know you very well, so it's okay. Thanks for this opportunity. Of course, it's an honor to be sharing the stage with so many of you, so many accomplished people, and of course, Sri Virendra Hegdeji. So I think the question is, I'll just stick to the point and not bore you guys with too many things. The point is about the mechanical education. I think if you look at how it is to my mind, I'm not a mechanical engineer, but I have got patents and designs in mechanical engineering. And why do I say that is not that I'm special? It's because it's a very fundamental life skill. So if you look at generally classify how we study things, mechanical engineering is something that comes bottom up. You take a screw, you take a nut, you take a part, and you create something out of a wooden piece in carpentry, in the shop during engineering, etc. But most of the other things like IT, etc., are more top down. You conceptualize something, you imagine something, then you bring it down to another level where it starts to react with the real world. But mechanical engineering starts with the real world. I sit in multiple colleges, academic councils, board of studies, etc. So based on that experience also, I'm going to make two points which might be against the grain here. I think there is not too much wrong with the curriculum. I think it will evolve and it should evolve gradually, not make a sudden change from black to blue. If there is a good churn, I think that will be good anyway. The reason for that is there is something called a half-life of education, which I learned somewhere, which means how long does it take before what you study, half of what you study becomes useless. Okay, just like a radioactive material. Today, I'm told it's 2 years. So whatever we do within 4 years of education, by the time we do the best, half of it is useless. So I think in that context, I think we should switch to what we teach to how we teach. I love the point in the opening remarks of Sri Virendra Hegde when he said, I think the interest is the key. I think if there is no interest, we can do what we want. It will not go anywhere. So I think the pivotal point for creating interest is with the teachers and the method of teaching, the pedagogy. So I think we should shift from what we teach to how we teach, and they have to move from what they learn to how they learn. So how could we do that? Just to keep it very crisp, I would think going back to the point of creating interest in students, showing them that they can trust you, trust the teacher, trust the person who is training them, that they can be a source of inspiration to them. Because today, students won't listen to you if you tell them. They are classical kids. They learn from what they see, not what they listen. So if I don't do something myself, they won't learn if I say only, walking the talk point of view. So what could we do? I mean, a lot of things we could do. I always encourage students. How many things, not students, even when I hire today, last week I was hiring someone in an interview, I asked the same question. What have you opened at home? Have you fixed a tap? Have you opened a flush? Have you checked inside a fan? Have you fixed a calling bell? What have you done? Because that doesn't take that you are an electronics engineer or a software engineer. Even software engineer need a cable and a set-top box to run their software. So the whole point is, how hands-on are you? What are you actually doing to make sure that you have touched? I can bet, Muni, I have interviewed mechanical engineers in my previous companies. They have no idea how many type of screwdrivers that exist today. I asked them, if you have to open a box, an iPhone or a set-top box or a computer, what do you need? He says screwdriver. I said, what type of screwdriver? He said, what do you mean, what type of screwdriver? They don't even know that there is a star screwdriver, there is a flat, there is a Phillips one, there is another one, there is So the whole idea is we have to tell them being experimental. So in my 4E concept, that's the second point I wanted to make. You have education, curriculum, okay, fine, we can do. You cannot learn swimming by the book. You cannot learn driving car by the manual. You have to drive to learn car driving, right? Similarly, after education, you get experience because you start doing it. Maybe if you're good, you become an expert because you do it so well. But what we need to inculcate is exposure. If I take the same example of the screw, education might teach you how to fix a screw. Experience is that you are experienced fixing screws for 10 years. Expertise that you are very experienced in a particular type of screw fixing. Now comes the fourth part, which we are not inculcating, is exposure. Have you fixed screws in a ship? Have you fixed screws in an aircraft? Have you fixed screws in a mixer grinder? Have you fixed screws in a switchboard? I think that exposure is what we need to bring. I think that's where I think we need to look at people moving from solution oriented to problem orientation. 60 to 70% of the top technical companies in the world are headed by non-technical people. Explain it to me. The only explanation that exists is they know which problem to solve, and there are 300,000 people to solve it. So we need to make people valuable. World Economic Forum skill says you need to develop critical thinking, because there is no product with one domain. If you ask Girish, he will say, my car has software. And if you ask Rakesh, he'll say, no, the software has wheels. So, and both are right. And they are just the amount of combination of technologies that have come together. I think that's where we need to have people look at, hey, you know what, let me find the problems that are worth solving. And that's what World Economic Forum skills says. You need to have critical thinking skills, creativity, and problem solving, because we don't even know what problem to solve. And that's where then the identity part is what I would like to close my point with. Let's not call myself a mechanical engineer. Let me call myself, I can understand mechanical engineering. I can do mechanical engineering design. I also understand AI. I also understand software. I understand product. More than anything, I understand the customer who is going to use my product. And I think if you can build these factors, I think you would have done a great job, because I think I still go back to my day one learning. If the learner hasn't learned, the teacher hasn't taught. Thank you, Muni. Back to you.
Oh, thank you, Sudhindra. It was a fantastic. Very interestingly, you did mention a couple of points. So one is this exposure, experience, and expertise, and experimental exposure or experiential exposure. That's fantastic. And you did mention the fundamental, the screwdriver. It's a fantastic point. As you rightly said, when you ask for a screwdriver, they don't know that. If you ask for a nut, they don't know that it has to be the size number, even the spanners. And in fact, somebody taught me, at least people can say, do you need a minus screwdriver or a plus screwdriver? It makes sense.
Absolutely.
Yes. Okay, to begin with. Thank you so much. And you also rightly mentioned that critical thinking is fundamental for engineers. Of late, there has been fairly good amount of effort by industry stalwarts to involve or include the critical thinking as part of the curriculum, as part of the activity in their projects. So that way, I think we should really take it forward. It's very, very valid point you did highlight. Thank you so much. And finally, your question was, I'm a mechanical engineer or electrician. That is not important. Do I understand engineering? Can I fundamentally solve an engineering problem? I think that is what we need to learn, and students should learn, and we need to enable them to learn as well. So last, not but the least, in fact, I would call, he is the host. He is the vice chairperson for our Bangalore section. He has initiated this program, so I would like to call him as the host. This is Mr. Girish Ramaswamy. He is the head of engineering, Bangalore Vitasco Technologies India Private Limited, with more than 20 years of rich experience in automotive domain. He's graduate mechanical engineering in 1996. After graduation, he worked with tier one automotive tier ones for a very long time. And joined the Siemens Information System, and he was part of various tier one companies, especially the European companies. And I do not know still how many students are available here in the call. Just would like to highlight that you have the OEMs and tier ones and tier twos. Most of the time, the customer would only know OEM. Let's say Tata or Mercedes or Honda, but a lot of companies are behind this. Without this tier one, tier two supplier, OEMs cannot survive. And these days, there's a lot of integration between OEMs and the suppliers. Especially, it is well known in Japanese market. They actually collaborate, co-develop, and produce the products. So our Girish Ramaswamy has got a rich experience in that. He has seen a lot of engineers, and his company has been growing. I'd like to ask him, you have been product of subsystems in this OEMs. The subsystems has become part and parcel of these automotives, and it is increasing day by day. what do you think is the role of mechanical engineers or associated engineers in the subsystems development, manufacturing, services in the industry? Over to you, Girish.
Yeah, thanks, Mani. Thanks for that wonderful introduction. And before I begin, and again, very big thank you to Dr. Hegdeji, who pushed both SAE as well as the SDM to bring, all the industry plus academia into one forum, which is happening today. Good to see that good amount of participant along with lots of questions on the chat window, which we'll see, try to address those things. Coming back to your question, of course, I think from my point of view, I think most of the previous speakers have spoken about it. But I would like to, come to a kind of understanding that is there any decline with respect to mechanical engineer compared to, say, electronics or computer science, which are predominantly, reference to software coding and all? Let's, accept that it's true. Let's not, say I think mechanical is good and that they are, not better than other things. That's not the question. But are they recruiting more people? Yes, I would say yes. And are mechanical engineers, inflow into the industry is coming down? I will say no. The reason is the base. A lot of you also talked about the core subjects, core, engineering departments and all. It stays. It is staying, and it will stay for future as well. Just consider, this mobile. This is a product. This needs mechanical engineering to design. But when you look at any kind of software that is needed on this mobile phone is very huge. A small mechanical product, surrounding that you can build lots of things using a software. That's why we need more and more people. So now coming back to the question of Muniratnam, how does it happen, especially in our automotive industry? I talk from the perspective of automotive because I am into R&D, especially in the four-wheeler segment, where when I started, it was pure mechanical, only with mechanical linkages the engines and vehicle used to run. And today, if you see in a car, we have more than 150 control units. This is how the software has developed, the electronics has developed within a car, and I'm being part of this journey so far. And whether this was taught during my education, I would say not fully, but I have learned over a period of time, encouraging myself to get into this electronics so that I can understand. So this is how the whole journey has started. So coming back to your question, whether because of this, the mechanical engineers' work will get reduced, I would say no. Predominantly because the base remains the same. Whenever we go from one technology to the other technology, we need mechanical engineers, whether in the area of right from design or development, or in fact testing. At the end of the day, putting these products or vehicles onto the road, it will be the predominant responsibility of the mechanical engineers who have the system know-how. See, when I started some mechanical many 20 years ago, being from mechanical industry, mechanical engineering, I could understand the system very easily. And my colleague who was a software, he was struggling to understand how does this engine works? How does code, what he codes gets reflected onto an engine? This he was not able to understand and think in terms of practical know-how. But that's the advantage of mechanical engineering. So today as well, even though we have this AI or whatever may be the newer technologies, the basic system know-how has to be there, because vehicle is a mobility where it has to move. It has its own functions where it comes out of this mechanical engineering only. But at the same time, as some of you also suggested, this has to become a kind of hybridization. Means we have to, bring in more and more electronics as well as software know-how, whether it's a cloud technology or a kind of artificial intelligence. I think we need to, bring all these things into this mechanical stream, which is the need of the hour. As Dr. Sudhindra pointed out, every 2 years or 3 years, these gets changed. We could see, or I could see in front of my eyes that we have changed lots of products within 2 or 3 years of time. Maybe it's because of the market demand or because of the legislation demand. But product does undergo a lot of changes, and we need all kinds of engineers, and we need all kinds of engineers who can understand the whole system basically going forward. This is, I think, we need to inculcate going forward. And at the same time, as somebody was talking about, we need to strengthen the industry and academia very much to come closer, work together, so that at the end of the day, the students get the benefit out of it. And at the end, I think as an industry, as a whole, not only the single mechanical stream lies there, but again, it coexists along with related departments in the long run. I think this is how I think we need to move forward, and that also change ourselves in the way of learning how we are doing today for the future. So that's a small statement from my side, Muni.
Thank you so much, Girish. In fact, it's very, very, very valid input to all of us and also to students, because you represents that OEM sector, which is much larger than, the tier 1, tier 2 sector. And as you rightly said, the basic remains same. What is important is so-called the system know-how, system knowledge. That is important even if you're a software engineer. If you don't understand how the mechanical thing works, you cannot develop a software. That's excellent. And in fact, now it's about 11:30. We have only 15 minutes. I have just two questions to specific questions. Then I will take up the questions posed by the students. One is to Naveed. Naveed, you are heading Society of Indian Automotive Manufacturers team under working group for the connected vehicles. What do you foresee the expectations from mechanical engineering students for electric vehicles? We are working on the connected cars.
Yeah. Well, we need to understand as to why this connected mobility thing has come up, where we are continuously talking about ITS, which is intelligent transport systems, and we have many cities now doing quality of mobility in the cities, and that is mainly because it was there to reduce the prime reason why the connected mobility or the intelligent transport systems are being talked about now, is to reduce the number of fatalities that we have. So I'll just put in some figures here. India, the current automobile numbers that are there on the road, this is pegged to go up as as much as about 200, I would say 2,000 million numbers on the road. And the current fatalities that we have, unfortunately in India, we are the worst in terms of the fatalities that are happening. Fatalities means the number of people who are dying. So the figure here is a little mind-boggling. It's like 17 deaths per hour we have on the road, which are happening. And therefore, the Ministry of Transport had directed that we need to look at reducing these fatalities, and in that this connected mobility space that we are talking about is very, very important. This is there to reduce uh, the traffic cities, and also it is to reduce the fatalities which are there. And therefore now what we are talking about is connecting the vehicle to the infrastructure, or vehicle to vehicle, like V2V, or we say that vehicle to infrastructure is V2X. So such sort of connectivity we are looking at. So now it's not going to be purely only about your uh, vehicles, it is about the quality of mobility that we are talking about. So the entire scope of engineering, it has shifted from only mobility to the quality of mobility that will be safe, and it will be more efficient. That's how it's moving across. And therefore today when we are talking about internal combustion engines, these internal combustion engines, after a few years, we many would not know what internal combustion engines were, because we are moving towards electric mobility altogether. And this electric mobility space, when we are talking about, many companies across the world today have already declared that by 2025, some by 2030, and some by 2035, will all move towards 100% electric mobility. So when, before, many panelists spoke about, the life of education that we have is, like 2 years. After 2 years, it becomes redundant, and whatever we have learned in the past 2 years, maybe by the time the student passes out, the first 2 years, what he has done becomes irrelevant. So similarly, the EV space is also a very, very similar thing to that. That what we are doing at the moment now may not be relevant in 2030 or in 2035. And if a life of an engineer that we talk about is about 50 years, we need to make him ready for these changes that are happening, and the change that is happening in terms of the kind of mobility, the kind of going to be there. And in future, it's not going to be only about automobiles. It's going to be about a collaborative effort where we the where we have a vehicle, but then inside that we have all the software systems which are there, which will actually drive the vehicle. And as we move towards the autonomous industry.
Thank you, Navid-san. Thank you so much for the forethought about the EVs and the importance of engineering in the future. Thank you so much. It's about 11:35. We have only 10 minutes to kind of conclude and wrap up. What I did, of course, just for the benefit of the students and the faculty, I just wanted to let you know that we actually framed a couple of interesting questions, but due to the paucity of time, I'm unable to run through. I will take the questions from the audience. I'll just read out, maybe we already have given the answers. We can debate that. Somebody said, Mr. Kote, make us comfortable with the subjects which are present in mechanical engineering and give us the brief information. What is the right course we have to choose? Because most of them will say join the course which we are interested in. But if anyone can give us the idea how to choose a course where both are benefited, who choose the course and also the course which is done by them. Well, I do not know whether, don't look at the aspect of the commercial engineering colleges. They would choose depending upon where the fees is high. But you should look at the organization where they're doing a relentless service on education. They're not going to tell you to choose this course. You have to choose the courses based on your personal interest. One is, any student from any branch will always get a job if he has got the right attitude. Okay. And that is one answer. What are different ways we bring in relevance to curriculum based on industry demand and also ensuring fundamentals of core branching? I think this has been answered by Dr. Ahuja that we are bringing in the industry experts to the academicians and discuss what is the right syllabus or what we need to do the tweaking on the syllabus, what the fundamentals which are being important. I think which feel that we have to, all the colleges or the university have to follow that. Sir, what is the scope we can get by choosing the mechanical engineering? I would not like to answer this if our panel discussion has not, if you're not able to get it, probably we are not on the right job. But I think all of us, I mean, this 6 panelists have given, each one of them come with 35 plus years of experience who have handled thousands of engineers, which means the experience what they bring onto the table is huge. Okay, I think somebody wanted to say something.
Muniratnam sir, this is Sunil here.
Yes.
Few more questions actually. Dr. Vadiraj Katti sir, he is being faculty with us.
Please.
So he had a few, one question actually, faculty skill updation to the needs of industry through faculty collaboration with industry. So there is some lacuna. So if anybody could able to bridge this or give some suggestions, it would have been beneficial to the teaching fraternity. And one more thing, what he has given is, since it is a changing era, so faculty has got a greater responsibility to cope up and then act upon. So these are 2 comments from Dr. Katti, Vadiraj Katti.
Thank you, sir. Probably I would request Dr. Ahuja to give the response for this because he's the right person and he has got a rich experience in connecting the industries and academicians. Can I request Dr. Ahuja?
Yeah. Thank you so much. I think skilling, we say upskilling, reskilling is very important, which applies to faculty. And I think once every 3 years, faculty should spend 2 months in the industry minimum. Right? So summer vacation in the industry where the faculty can work on live research projects, get hands-on, and bring that research into the classroom by way of experiences and teaching what the faculty has learned from the industry. It's an ongoing process. If I have to remain a teacher, I have to myself be a lifelong learner. And today there are so many courses available that I can take any course which is available online from the best of teachers in the world, and I can keep learning and evolving myself. So why should we mandate that only students should go to the industry? Why not every faculty go to the industry? I think that is very, very important, right? And more important is that can each faculty develop his or her own coding skills, his soft skills. So soft skills is something which is very integral to teaching today, no matter what kind of engineer I am. So I must also learn coding techniques and I should not hesitate. You know, it has taken me 30 years to realize that I am not a teacher. All along I was thinking I'm a teacher, till the day it dawned upon me that students are my teachers. I learned more from my students than I actually teach them. So I think if one goes with that attitude and one is prepared to go to the industry and learn different things, I think that will help the faculty if I have to remain a teacher today.
Okay, thank you, sir. Thank you for your wonderful explanation on the question. Thank you so much. And I think we are very close to the panels. I would probably like to sum up the panel discussion. If you allow me, all of you allow me. One is that panelists, the distinguished panelists suggested that we need to work on the interdisciplinary project. I mean, I think it's extremely valid and less talk and do more. Probably we should adopt that. And other thing is, what is before Corona and after Corona? How do we evolve ourselves? Then the 3 pillars: faculty, students, and curriculum, and collaborative teaching. And other point is working together. This is something fundamentally we have to learn during the college, not just the type of engineering, but how do we work together in a team, and soft skills, and the exposure, experience, expertise. How do we do that? And the problem to solution and critical thinking. These are the couple of points or major points shared by our distinguished panelists. So I know that we had many questions and also a lot of thought process for us to share with the students. Due to the paucity of time, I would like to end here. I would like to hand over to Professor Sunil. Before that, I would like to thank all the panelists for having spent over 2 hours in sharing your rich experiences with the students. Thank you, Dr. Sudhindra Kaushik, Dr. D.K. Subramaniam, sir, Dr. Sudhindra, Mr. Girish, Mr. Rakesh Bidre, Mr. Naveed Salib, and Dr. Ahuja. Thank you so much, sir. And I also request colleges to closely get associated with SAEINDIA, because we are existence for the engineering community. We are part of the standards development. We are educating the students. We are educating the faculty advisors. We are also doing a couple of programs for school students to bring in STEM approach. So with this, I hand it over to Professor Sunil sir. Thank you, sir.
Thank you, Muniratnam sir. Really, it was awesome. You were moderating the session and then precisely winding up what are the outcomes of this thing. And also, you have extended faculty to collaborate with industry through SAE, which is in fact need of the hour. We need to explore, as Dr. Ahuja also mentioned. So we have to learn and unlearn every regularly. So thank you, sir, for moderating the session and presenting your concluding remarks. With this, yeah.
I have one request from office team. Sometimes, they have this digital formality of taking a photo of all the panelists. Can I request office to kind of ensure that we switch on cameras?
Okay, I think SAE, since they are hosting, they can able to do. And our principal, actually, there is one more meeting going, sir. Parallelly, he's a member of LIC visit, so he's attending online of that. So
Yes.
he just mentioned he is unable to. And our president also, there is a one more cabinet level
Sure.
meeting in Bangalore. So he has also just this one exited from the meeting. So with this. In fact, a photo session, will it be? Will it continue, or should I wait for some time?
Whoever is available, we can ask our
Please.
host.
I think they can even take a screenshots probably.
That's what they do.
Okay, fantastic. Then I will continue, sir.
Yes,
so with this, we have come to a concluding session of this panel discussion. I request Mr. Venkatraj, Deputy Director General, SAE India Bengaluru chapter, to propose vote of thanks. Over to Venkatraj, sir.
Thank you, Professor Sunil. Good afternoon, gentlemen, my dear students. It was a great session. Sat through the whole thing. I think it's a very healthy topic for today. I wanted to finish it very quickly. Dharmadhikari, reformer and educationist, Dr. D. Dharmendra Hegde, thank you so much for creating about 18 institutions in Karnataka and excelling this. Thank you, sir. And Dr. K. Gopinath, professor and principal of SDM CET, for giving shape to such an esteemed institution. You talked about interdisciplinary branch projects. That was a good point. Thank you so much. I know you're not there. And Dr. K. Subramaniam, retired professor of IASC, member of Governing Council, SDM CET. I think the valid points of driverless cars, and we are going through the next version of mechanical engineering. We all have to look at it. These are the points or giveaways. Thank you so much for joining. And our own board member, Mr. Naveed Talib from Honda Cars India. Thank you, Naveed San. I think you brought in valid inputs from Japan, India, I think 2 cultural points, and the importance of mechanical engineering. Thank you. And the alumnus of the first batch of SDM CET, and also our supporter, long-term supporter, Professor Bibi Ahuja ji. I think that was a great discussion. Like Mr. Muniratnan said, you have talked about Mr. F.C. Kohli's quote on tripod. That was really an enjoyable thing, and the North Principle, I would say. Thank you so much. We would like to continue to be associated with COEP and SDM CET. Our own Rakesh Bedre, one of the pillars of REEF, you touched upon the fail first. That was super. Thank you, Rakesh. And Dr. Sudhindra Kaushik, a very valid point. And it has given a cross-section of mechanical engineering from the innovation perspective and the 4 E's. Thank you so much. We would like to utilize your expertise in one of the professional development programs in the coming months. And Mr. Girish Ramasamy, our long supporter, and section and several programs. Thank you for bringing up the system thinking. We've been doing this. We have conducted, co-hosted a system thinking conference. Thank you for organizing or conceptualizing this. Thank you. And Damo, the chair of Bangalore section, for spearheading the one of the vibrant sections of SAE India. Thank you so much. Mr. Muniratnam, the past chairman of Bangalore section, who spearheaded the section for several things, and also our Aero Forum leader until recently. Now he is our chairman for Engineering Education Board, one of the richest boards and one of the active boards who conducts several programs for students. Thank you, Muni, for an excellent moderation of the session, and the summary was super. Thank you, Professor Sunil. I know at the background, you may have to put a lot of work, and the script was good. I learned a lot about SDM and the SDME society. I wish I come there sometime. Thank you, students, for patient hearing. It was 118 people in the beginning, and it is sized because of various other meetings. It was a great program. Thank you, everybody. Have a good day. Stay safe. Stay home.
Thank you, sir. Thank you.
Thank
Thank you, one
you.
and all. Thank you. Thank you. Thank you, one and all.
Thank you. Thanks a lot.
Dhanyavadalu. Good day.
Thank you.